Okay, elimination. Hopefully you guys got pumped up for solving a system of equations using elimination. You can sing that when you guys do your math. It'll help you out, get you pumped. Alright, so first step solving elimination problems is you need to recognize when to use it. And so if you look at this equation right here, these two systems of equations, one thing will jump out, and that this term is identical to this term. So if you have two terms that are identical, if you have two terms that are the same, you should think elimination, because it'll be easy to solve for your other variable. Okay, let's show that. So in this case, the x's have the same coefficients, so therefore I'm going to be able to solve for one of my variables very easily. So step one in this is we're going to make sure that the coefficients in front of one of the variables is the same. Then subtract the equations in front of these two words. Okay, so that's our step one, is that we are going to make sure the coefficients in front of one of the variables are the same. So in this case it's the x's, and then we're going to subtract the equations. Okay, so when I do this, when I subtract the equations, let's put in a negative sign. Let's actually move this to the side a bit. Okay, that's better. And I'm going to subtract these now. So when I subtract them, you can think of subtraction as I'm subtracting everything. But what that does is by subtracting this whole bottom equation, that changes by distributing this negative sign. That's the same as changing every sign in here and then adding. So that becomes a negative, this becomes a positive. And now I can just simply add my equations. So when I do that, 2x, negative 2x plus 2x goes away, so I get a 0. A 3y minus 7y gives me a negative 4y. And then a 1 plus 3 is equal to 4. So look how simple that is. They cancel out, and now I divide both sides by a negative 4. 4 divided by negative 4 is a negative 1. So I get y is equal to negative 1. So after I subtract the equations, this step is simple. I'm going to solve for my variable, my single variable that I have left in the one equation. And that's using algebraic techniques. Now this is step 3. It's the same, step 3 and step 4 is the same as the steps from the substitution method. Now that I have this, step 3 is I can use this solution and substitute it into the other equation, or into any of the equations, to solve for my other variable. Kind of wordy, but when you guys see it done, you'll be like, oh, that's pretty simple. So it's not too hard. Okay, so use this solution to solve for my other variable. So since I have y, let's put this in green. So y is equal to -1. So let's bring this equation down here. So I have negative 2x plus 3. Now here's where I substitute in my -1 is equal to 1. So let's put this -1 right in here, and let's solve for my x. So I have negative 2x minus 3 is equal to 1. I'm going to add 3 to both sides, so I get negative 2x is equal to, if I add 3, that becomes 4. And x, if I divide both sides by -2, I get x is equal to -2. So there's my other point. So now my solution is x is -2 and my y is -1. Okay, so let's plug these in here. -2, this one in red, -1. If I come over here and I plug that in, -2 times -2 is +4. +4 plus, this is a -3. +4 minus 3 is equal to 1. So that checks out. So that's good. And let's do it down here. So we have a -1 and a -2. And I can keep the positive and the negative here because it's consistent with everything. Or I could take them out. It doesn't really matter. Let's take them out just for this case. Okay, so -2 times -2 is a +4. +4 minus 7, -1 times 7. +4 minus 7 equals a -3. So that checks out too. So therefore, I've just done step 4, which is check my answer. Alright, so what that means is that I just solved this system of equations using elimination. Eliminate the right, eliminate the wrong, eliminate the weak, eliminate the strong, eliminate the feelings, eliminate too late, eliminate the hope. Okay, last thing I'm going to show you is special cases. This is cases where you're going to get the answer of either no solution or an infinite number of solutions. So it's infinite. So one or the other, these are special cases. So I think the easiest way to see that is, let's look at this problem right here. And let's just keep regenerating. That was a problem that we did before. Let's regenerate until we see one that will be a special case. And right here, this looks like a special case. So if you look at this, let's go ahead and subtract this. And let's look at what happens. So when we subtract this, remember that subtracting the whole thing is like adding the opposite. So we get negative 9x plus 9x, well that's 0, 6y minus 6y, well that's 0, and negative 9 plus 9, and that is 0 again. So we get 0 is equal to 0, and if you remember from the other video, if you get 0 is equal to 0, that's the infinite number of solutions, because it's the same line. It's the same exact thing. Both of these are the same equations, so when you subtract them, you just get 0 on each side, which makes sense. Okay. Alright, so let's see this again. Let's see if we can find another one that's a special case. See if you can spot it out as well. Ooh, okay, great. We got another one right here. So if you look at this one, let's look what happens when we subtract this. Remember, subtracting, it's like changing the sign of everything and then adding. So let's look at this. 2x minus 2x gives me a 0. 8y minus 8y gives me a 0 again. And then 4 plus 6 gives me 10. So I get 0 is equal to 10. Well, that's not true. 0 is not equal to 10. So therefore, I get this not equal to. It's like nonsensical answer. So that doesn't work. So therefore, what's the answer to this? And it's no solution. So remember, if you get 0 is equal to 0, or 1 is equal to 1, or 2 is equal to 2, that's infinite solutions. But if you get a nonsensical answer, like 0 is equal to 1, or 0 is equal to 4, or 1 is equal to 3, well, those are all not equal. So none of those work, and you get no solution. Alright, hope you enjoyed this video, and that now you can solve systems of equations using